Okay, hey Chloe, it is Tuesday. We are doing some more on 4-6. We'll probably get done with notes today, honestly, on 4-6. Here's the homework assignment, but they wanted to go through problems 22 and 36. So I put them down over here, and I just figured you probably want them too, so we're going to record those guys. So 22, they just want us to graph this thing, right? Okay, so let's figure out, I'm going to go amplitude, period, phase shift, vertical shift. It goes like A, B, C, D, right? And we got to figure out what we have, right? So which parts do we have out of A, B, C, D? We have an A, which is 4, and we have a B. What is B? Like this guy, I don't like the way that he's written, so I'm going to change him to say 1/2 X. So that means your B value is 1/2. Oop, B. Okay? Now, the negative, I'm just going to put a star here that says flip, because we're going to flip him down. And that's what that negative is going to do. So that's not a part of your A, B, C, or D, but just note that, like below, okay? So amplitude is 4. We don't have a phase shift. We don't have a vertical shift. So that makes them kind of nice, all right? Now, if B is 1/2, how do you find the period? It's a little tiny teensy-weensy formula. 2 pi over B, and B is 1/2. So 2 pi divided by 1/2, you're going to keep flip him to the top. So 2 pi times 2 over 1, so 4 pi. So we've made him wider and taller, right? Okay? Okay, and instead of graphing secant first, let's graph cosine, right? Or don't. Megan doesn't like to graph cosine first, but I like to graph cosine first. Okay, now we're not shifting him at all, and he stays like in the middle, so I'm going to do just one of those, right? And normally he goes from 0 to 2 pi, but now he's going to 4 pi. So I'm going to make my little markings here. That means these guys would be pi and 3 pi, right? That's where he would be now, okay? And he's going to go up to 4 and down to -4. So I'm just going to make those markings there, all right? And yeah, so cosine has to live somewhere in this little box right here. That's where cosine's going to live, in there, okay? Now, normally, let me undo my little box. Normally, cosine goes like this, whoop, right? Like that. But don't forget to flip him. He goes the other way. So my dots are going to go here, 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 right? And he goes something like this. Oh, gosh. My thing is not very good. Okay, there you go. There's what negative cosine. That's cosine. Now we just have to do secant, and that's it. And then we'll be done with this problem. Okay? But before we graph secant, let's do the vertical asymptotes. Where are my vertical asymptotes going to live? Where he crosses the middle line. So my middle line crosses right here and right here. It's like where the, like half the distance between the high and the low. High is here, low is here. It's like halfway between, right? So vertical asymptote, vertical asymptote. So he is here and a whole one here, which is kind of wide, right? And a half of one here, okay? The orange one is secant. The purple one is cosine. Yeah. Let's go to 36 and then we'll bump back to 20 because I don't have 20 written down. Okay? All right. Are we good on 22? Are we good on 22? Okay. 36 is a little bit different. 36 is a little different. Yes, so they want us to write what cosecant is, right? This is a graph of cosecant, okay? And we just have to figure out what B and C are, okay? There's no amplitude change. Do you see that there's no amplitude change? He's going from 1 to -1. So there's no A, right? There's nothing that should go here. And he's not shifted up or down anything because his middle line is at 0, right? He's equal distance from 0. So there's no D here, right? But there is a B and there is a C. We have changed the period and we have changed the, like, where he starts at, right? Okay, so where is he starting at? He's starting at pi over 8. So we have shifted him to the right. I'm just going to write down information that we know, right? He's moved to the right pi over 8, and then he stops right here. So how far apart is pi over 8 and 9 pi over 8? That's where he ends. He starts at pi over 8, and he goes to 9 pi over 8. Okay, and if I subtract those two, that's a difference of 8 pi over 8, which is pi. So that means that the period is pi. Okay, yeah? All right, so I'm going to find B first. And this is where we're working kind of backwards, right? To find the period. To find the period, I take 2 pi and I divide by B to get the period. But now I know the period. The period is pi, so I put him there, right? So how do I solve for B in that case?
Switch them.
Yeah, I can switch these two around, right? So like I put pi here and B goes here. So B is 2 pi divided by pi. So B is 2. Do you see how that works? And if you think about that in your head, okay, 2 pi divided by B should give me the period. If B is 2, then that's a period of pi. So that works out. So my B value should be 2. So right now we are at y equals cosecant of 2x minus c, and I got to figure out what the c part is. That's the last thing, okay? Now, I'm going to the right pi over 8. That's how I'm shifting it. So negative c over b has to be equal to pi over 8, right? Negative c over b is equal to pi over 8. But we know what b is. What's b? 2. So how do I solve for c in this case? You could cross multiply divide.
That would be a little
I mean, you could if you wanted to. It's not that big of a deal. Or let's just take and let's multiply by negative 2, right? Because right now c is dividing negative 2. Let's multiply the negative 2 to the other side. Times negative 2. Can we do that? Okay, so c is equal to pi over 8 times negative 2. I'm going to make that into a fraction, negative 2 over 1. Pi times negative 2 is negative 2 pi over 8, which is negative pi over 4. And that goes here, minus pi over 4. That's what he is.
But isn't minus pi over 4 to the left?
If it's in the equation, minus means to the right, right? Like if he's like, let's say x plus 3 squared, right? Inside here, that means to the left 3, right? So it means the opposite. But once we pull it out here and it's to the right pi over 8, then it's exactly the sign that it should be, right? But in the equation, it's wrong, right? In the equation, it's the opposite. Do we see how that works? Yeah. So instead of doing plugging in for B and plugging in for C, you're saying negative C over B is equal to this, or 2 pi over B is equal to that, right? Okay, good? Kind of messy. It is a little messy, okay? But that's what he should be. Got it? And yeah, that's it, because sine would have been this guy, right? So yeah, he's perfect. Okay? Do we need to go through number 20? You did it? It's not that bad?
22 again. Okay.
That's 22. Yeah? Okay.
Tangent and cotangent.
No.
All right. Tangent and cotangent. Here we go. Grab your pink sheet.
It looks
We're going to graph tangent and cotangent, and we're going to put them on this guy right here. Do we have room? Yeah, we have these two guys down here. Do you guys have this at the bottom somewhere?
Yeah.
We'll try to avoid him. We'll try to, like, make tangent smaller-ish, kind of.
This looks really ugly.
Okay. It's not that bad. It's not that bad. It's honestly not that bad. Okay, so we're going to graph tangent over here. Y equals tangent of x. And we're going to graph cotangent over here. Y equals cotangent of x. And those are the other two, the only two that we have left. Okay? All right, and I'm going to, when you graph this guy, do this. I'm going to give a little room on the left and the right. Okay, because we will graph some to the left side. So he's not just all over here. He is a little bit to the left and to the right. Cotangent, you can do the same thing. Yeah.
Except he'll need more.
He'll need more room on the right. Yeah. Okay, because there's a little bit of a difference. Okay. All right, so get those guys ready to go. We'll add them to our sheet. Now, this red sheet, or pink sheet, or whatever you guys call it, the unit circle, you guys get to use him on tests and quizzes. So even if your like mind blanks out and you're like, oh my gosh, I forgot what sine looks like, you have what normal sine looks like, and then you just have to alter him according to what the numbers are in the thing, right? Okay. So just so you know, he is there for you. Okay. All right. We know the relationship between sine and cosecant, right? They're just like the parabolas that are branching off of them. Same thing with cosine and secant. Okay, tangent and cotangent have a little bit of a different relationship. Okay, here's what tangent looks like. Ready? First and foremost, the period of tangent is
2 pi.
not 2 pi. all of these other ones above here. The period was 2 pi, the period was 2 pi, the period was 2 pi. Like, it's 2 pi before he copy and paste to the next one, right? Tangent is not that way. Do you remember what tangent was? Tangent is only pi, okay? If you look at your unit circle after 180 degrees, tangent starts to repeat again, the same values. So tangent's period is pi. What do you think cotangent's period is?
Pi.
Also pi, right? Their partner has the same period as what they have, right? Okay, so since cotangent goes with tangent, that is the only one whose period is pi. All the other 4 are 2 pi. Got it? Okay, so here's what tangent looks like. Ready? Tangent does not do the little curvy wave thing like sine and cosine, okay? Tangent looks a little different. Here's what tangent looks like, okay? Tangent starts on this side, and he has a vertical asymptote, okay? And he goes to this side, and he has a vertical asymptote. This is what one period of tangent looks like, all right? Now, I'm going to ask you some questions. Let's see if we can figure this out on our own. And Megan already knows the answer because she has it in front of her. Yes, put the graph of this guy in here. So he has a vertical asymptote on the left, and he has a vertical asymptote on the right. This is what one period of tangent looks like, okay? Now, here's my question to you. If tangent's period is pi, that means there's pi between here and here, right? If there's pi units between there and there, where is this mark at and where is this mark at? Yeah, a half a pi on the left and a half a pi on the right, right? So pi over 2 would be here, and negative pi over 2 would be here. Those are where the vertical asymptotes are, where 0 lives in the middle. Does that make any sense? If pi is his distance, he's a half a pi on one side and a half a pi on the other side. Got it? Okay, that makes sense. Here's what tangent looks like. Very, very easy. He reminds me of x to the 3rd power. Okay, do you know what x cubed looks like? Don't write this down. Do you know what x cubed looks like? Like that, right? That's what x cubed looks like. Now, the difference between tangent and x cubed. X cubed, this guy, as he goes up, he will continue to go out. Tangent just goes straight up, and he is bound by this line. He doesn't go past it, right? Whereas x cubed would. I'm going to make him a little bit more curvy. Like this. Okay, and then he goes down like this. He is exactly x cubed, except he stays within his boundary walls, right? He doesn't continue to go out as he goes up. Like this one will continue to go out as he goes up. He's bound by those 2 little guys, okay? Now, one more thing that I'm going to have you write in here, and it is this. If this is pi over 2 right here, where's this little halvesy mark at? Pi over 4, okay? So at pi over 4 and at negative pi over 4, okay? He is at 1. And this guy is at negative 1 at pi over 4, right? That's where he will hit, okay? So tangent kind of has like 3 points. He has this middle point right here, and then he has his 1 and his negative 1. Now, let's say instead I say, okay, we're going to graph y equals 5 tangent of x. What does that mean? Like this first dot will look like this, and he'll go like straight up almost, right? Okay? He'll have a really high amplitude kind of, right? Okay? So that is how that works. All right? Got it? So vertical asymptotes, all of the things. Good, good? We're going to graph cotangent. Are we ready for cotangent? Are we going to graph what?
This one has 2 on there.
Oh, do we want to graph another period? Sure, we can.
Why
Okay.
Why is it like that?
I don't know, just so that you can see another period, because sometimes they'll ask for 2 periods of tangent. Okay, so here's the deal. Tangent's period is 1 pi, right here. Like the distance there is 1 pi. This mark right here for the vertical asymptote is a half of a pi. If I go over, where will this vertical asymptote be?
3 pi.
3 pi over 2. Because if I add a pi to 2 pi, it'll be a pi and a half, right? 3 pi over 2. Okay, that's where he will be. And then tangent, if we do a second period of him, he'll look like this. Whoop. Whoop. Okay, so that is technically 2 full periods of tangent. Got it? Okay, sometimes they'll only ask for 1, sometimes they'll ask for 2. Just so that you can get the pattern. Okay? That's the second period of tangent. Okay? Oh, where is this middle marking right here? Where is this guy? He is at pi, so if you want to put a pi mark right there, that's fine. That's where he will hit, right? Because if he hits here at 0, he'll hit again at pi because the period is pi, right? Everything's just the distance of pi apart. Okay? All right? Good? Cotangent.
It's just flipped.
Kind of.
Like,
It'd be nice if he was just flipped,
it
right?
moves
So
over
if we
at
flip
pi.
him, here's the deal. If we flip him, he looks like this. Don't write this down. If we flip him, he looks like this and he goes like this, which is true, except for he is also, I think cotangent's easier than tangent because cotangent's vertical asymptote starts here, and then where will he end over here? Where will his other vertical asymptote be? At pi, because why? Because the period is pi, right? So if there's a vertical asymptote here at 0, there's got to be a vertical asymptote at pi, right?
Why is it vertical asymptote?
yeah, why aren't the vertical asymptotes at half?
They're not at the same spot.
Why?
Or why?
Because it's kind of like how cosecant and sine are kind of the same relationship to each other, just moved over pi over 2, or pi over 2, yeah. Cotangent is moved over pi over 2. Weird. I don't know. Yeah. Okay, and he goes down the other direction, okay? But otherwise, everything else stays the same. So this is cotangent. Yes, you can write this, okay?
See, I told you.
So that's what he looks like. Where is he going to touch this middle section right here? Pi over 2, right? A half of a pi, okay? At, what's the halvesy mark in between 0 and pi over 2? Pi over 4, he's going to touch at 1. And he's going to touch negative 1 at this marking right here, which is at 3 pi over 4, right? 3/4 of a pi, right? He's going to touch at negative 1, boop, right there.
That makes sense.
Okay, so that is cotangent. Now let's do one more period. Where's my next vertical asymptote going to be? Right here. 2 pi, right? Because if the period is pi, if he has a vertical asymptote at 0 and at pi, he'll have another one at 2 pi. Okay, and at, what would that be? 3 pi over 2? 3 pi over 2 is where he will touch the middle section and he'll go like this again. So he goes downhill and he's shifted over slightly. If you compare tangent, he's going the opposite direction as what tangent is, and he's shifted over. So his vertical asymptotes are nicer because his first vertical asymptote is at 0.
This isn't.
It's not too bad. Oh yeah, should we do domain and range? Let's do it. They're not too bad. Okay. Oh yeah. Finish doing him, and then we'll do domain and range here in a second.
Domain and range for sine and cosine.
Did we not do domain and range for sine and cosine?
We only have domain and range
For secant and cosecant. Okay, let's go back up and we'll do domain and range for those two. Okay. You want to backtrack to them, or do you want to do tangent and cotangent first? Backtrack to them. Okay, sine and cosine. All right, let's do domain and range for sine and cosine. So add these in here. Domain and range. Okay, domain is left and right. For sine, left and right. Because he's just waving back and forth all the way through. Left and right forever. Okay, range is up and down. Will he go up forever?
No, only up to the amplitude.
He only goes up to the amplitude, like
The
1.
amplitude can be-
So, but this one is just domain for just sine of x.
Yeah.
So for just, if we're just talking just sine of x, what's his range? From -1 to +1. Will it hit -1 exactly?
Yes.
Yes. So bracket, will it hit +1 exactly?
Yes.
Yes. So he's bouncing around between -1 and +1. Now, if that amplitude is 7, he'll go from -7 to +7. Okay. So he has the possibility to go as high as we want him to. But if we're just talking sine, he's only going to go -1 to 1. Okay. All right. Cosine, domain and range. Domain, left and right,
Yeah.
forever. Range, up and down,
Forever. Or no. -1.
just -1 to 1, right?
Sorry.
Okay. Unless we switch his amplitude, because then he'll just go up as high and as low. Okay. But he will touch -1, he will touch +1, and he will just bounce around in between those two. Got it? Sine, cosine. Okay, are we ready for, am I going too fast? Tangent? Okay, let's do tangent. Domain and range. Which one's easier? Range. Range is up and down. Will he go up and down forever?
Yes.
You betcha. He's going to be all reals for range. Domain, though, is all reals except the vertical asymptotes.
Pi over 2.
What's that?
Intervals of pi over 2.
But see, Intervals of pi over 2. Yes, he has a vertical asymptote at pi over 2. But technically pi is also an interval of pi over 2. Does that make sense? So, let's say his first vertical asymptote is pi over 2, right? Pi over 2, and then how much later is his next vertical asymptote? Plus pi k. Does that make sense?
Yeah.
So intervals of pi after pi over 2 is where he's going to have a vertical asymptote where he's going to poop out. Does that make sense?
Yeah.
Okay.
Now
All right.
for the next one is the same, except it's just
So cotangent, I don't know where I should put domain and range. We'll put domain here. Domain, range. Which one's nice?
range.
Range up and down. He will go up and down forever. So the range will touch all values of y. Domain, though, he has a vertical asymptote at 0. And again at pi. And again at 2 pi. So he will be all reals except for,
0 and interval.
yeah, so you can say like 0 plus
Okay.
pi k. Or you could just put pi k. Any intervals of pi. Okay? That would cover it. Got it? So cotangent has a similar domain to cosecant. Right? Because this is everything except for those vertical asymptotes, and the vertical asymptotes are the same. Anyway, all right. Okay, let's go graph some tangents and cotangents and all the things.
Amplitude is 3.
Go to example 3. Graphing a variation of tangent. Oh, we only have these 2 left. Awesome, I love it.
No.
Yeah. Okay, so we still have amplitude. What comes after amplitude? Period. What comes after period? Phase shift. What comes after phase shift? Vertical shift. It's A, B, C, D. But, yeah, right. We don't have the last 2. We don't have a C and we don't have a D. Can you tell that?
Yes.
Like this guy right here is a parentheses. My C would be here. My D would be here, right? Okay. So there's no C, no D, so no phase shift, no vertical shift. The amplitude is trace, period. Oh boy.
Oh boy.
How do we find period? What's the little equation? 2 pi over B,
1/4.
except.
It's 1/4.
No, hold on.
That is.
No.
No.
It's not 2 pi over B. For tangent, period. Period is not 2 pi over B. Hold on. Period is not 2 pi over B for tangent. How do you find period for tangent? Just pi over B, right? Why just pi over B? Because tangent is just pi, right? Normal period for tangent and cotangent is just pi. So it's not 2 pi over B, it's just pi over B.
I don't like that.
Woo! So it's pi over B. What's the B?
Pi over 4.
B is pi over 4, right? Get rid of the x, so pi over 4. So I have pi divided by pi over 4.
I don't like that.
This is pi. I'm going to put pi over 1. This is like pi over 1 on the top, right? Times 4 over pi. So what's the period now? 4. How can I have a period of just 4?
It's like basically.
What?
It's basically.
Yeah, 4 is a little bit more. It's like 4 radians, right? Pi is 3.14 radians. So it's a little bit bigger than pi. Yes. So you won't put pi's in there. So you'll just label him with solid numbers. Does that make sense? Let me make him go left and right. So your x-axis will not be in terms of like pi and 2 pi. He will actually have legit numbers, which sometimes is easier, right? So he's going to go all the way to 4, right? And then here's 2. And then here's -2. And then here's -4. And we'll write all the things, right? Okay, we're graphing tangent now. Okay? Tangent overlaps 0. So he has a vertical asymptote over here and over here, right? And he is 4 units wide.
I don't like this.
So where are his vertical asymptotes going to live? He is 4 units wide. So he's going to go from -2 to +2. Do we see how that works? He's 4 units wide. Then the only other thing that I have to deal with is, what's this halvesy mark right here? 1 and -1. At 1, he's going to hit how much? 3. At 1, he's going to hit 3. And at -1, he's going to hit -3 because that's my amplitude. So he looks like We see how that works? He's going to be kind of taller and skinnier than normal. Yeah, weird. Weird stuff. Weird stuff.
Let's do the next one.
Okay? All right? Happy with that? Now we're graphing cotangent. All right, now we have a what and a what?
Phase shift.
Now we have a phase shift, vertical shift. So amplitude, period, phase shift, vertical shift. Okay, amplitude is what? 1. There's still a number 1 in front of here, so we'll just put 1 for amplitude. What's the period?
Pi.
Still pi. If we had a b value, we would do pi over b, right? Okay, but we don't. So phase shift. How do I do phase shift?
C over
Is it still negative c over b?
Yeah.
Yeah, it is.
It is.
So negative c. What's c?
2.
Negative pi over 4 over b. What's b? 1, right? B is 1.
I'm second.
Okay, so negative pi over 4 over 1, which is negative pi over 4. That's moving him to the left pi over 4, right?
Wait, but
Which-
I thought that
Phase shift.
Up here, plus means left, right? Once you pull it out in the equation, minus means left. That was clear as mud. All right, plus 2. Up 2. Vertical shift. Up 2. Right? Yeah? Oofda. All right, here we go. Okay. All right, we're going left a little bit, so I'm going to, like, put him to, oh, and I'm going to do this. Whoop. I'm going to do that. Can I do that? There's my x and y axis. Got it. Okay, where should we start?
I mark your x-axis.
Mark my, like, oh, mark your x-axis? Okay. So normally cotangent goes from 0 to pi. Boop. Right? This would be pi over 2. This would be pi over 4. What's this? 3 pi over 4, right? 3 pi over 4. Except I'm going to the left pi over 4.
So make them pi over.
Okay, this amount is pi over 4, right? That's pi over 4 amount. So I'm going to put left pi over 4. So rather than starting here and ending here, I'm going to start here and end at
3 pi over 4.
3 pi over 4. So those are my vertical asymptotes. Okay, do you see how that works?
So in the middle of that is
In the middle, we're going to go, oh, what's in the middle then?
pi.
It should be pi over 4 right here. He just looks a little less. Mine's just shifted over. So that's where he's going to hit. Oh, except he doesn't hit there. He's up 2. So he's going to hit right here. This is my middle line right here now. Okay? He's going to hit right there. And then from there, so here's 2. From that dot, my amplitude is 1. So at pi over 2 right here, he's going to be up at 3. And here, he's going to be at 1. Do you see how that works? And the, oh, wait. And he goes, gosh dang it. Gosh dang it. I lied. Oh, no. He's here at 3, and he's here at 1, because he goes downhill, right?
That sucks.
That's what he looks like. That's cotangent. Ugh. He's up 2, amplitude of 1, period of pi, left pi over 4. Like, do your little crosshair marking things, and then it will be easier. Okay?
Don't like
Okay. How about that?
homework.
Done. Right?
We only have 3 problems.
We only have 3 problems. So what we'll do tomorrow is we need another whiteboard day. Yeah. Yeah, to graph these guys, especially graphing tangent, cotangent, right? Are we feeling good about sine and cosine?
Yeah, sine and cosine are easy.
Yeah. Cosecant and secant, we'll practice them a little bit, but they're basically like sine and cosine, kind of. So we'll practice some of those tomorrow. So, Chloe, I will record whiteboards tomorrow. So just so you know, we won't be doing any more notes, but there's that. So these are the homework problems to add. That's tangent, cotangent. Yeah, we've already done 22 and 36 for you. So you only have like 5 homework problems. I say that like it's easy, but graphing is like a beast. So anyway, okay, bye, Chloe.